On April 5th, we got out of bed about 4:30 in the morning, ate breakfast, checked the weather, got suited up, and jumped in the Astrovan to ride to the launch pad. I frankly didn't have a lot of confidence we were going to launch that morning. It was raining at the time, but the weather cleared and off we went.
After what was a textbook countdown and a very short hold, the liftoff was, I might say, entirely nominal and entirely exciting. The engines started at T-minus 6 seconds, followed by SRB ignition and roll program to a direction of due east off the pad. The vehicle, its 4.5 million pound stack with orbiter tank and SRBs, continued to accelerate upward and going faster and faster through ever decreasing density air. We approached the point of maximum dynamic pressure, about Mach 1, and here you can see shock waves standing off the frustrums of the solid rocket boosters. The first stage continued for approximately 2 minutes, at which time the solid rocket boosters had expended all their fuel and they were jettisoned into the ocean. Here you see the boosters being separated, and as they continue to burn out, they would parachute back into the Atlantic Ocean for recovery and analysis. Main engine burn continued for a total of 8.5 minutes, at which time we achieved our MECO velocity on target and set ourselves up for OMS 2 burn and arrival on orbit.
One of the most significant events that we perform early after getting into orbit is the opening of the payload bay doors, which you're seeing here. Not only is this significant for us to set up shop and to be able to stay on orbit, but it also provided us with our first very beautiful view of the Gamma Ray Observatory back there in the back end of the bus, and that's the prime reason we were there, and we were all ready to go to work. The opening of the doors also gives you an opportunity to use those aft windows to take a look at some of the Earth's beautiful views, and this was an early one as we came across northeastern Africa.
On flight day 2, we set up some preparations for deploying the Gamma Ray Observatory. Those were 3 main types. One was getting the Gamma Ray Observatory all checked out in cooperation with the Payload Operations Control Center and Goddard Space Flight Center in Greenbelt. The second was to prepare ourselves by pre-breathing pure oxygen so that when Jerry and I went down to 5 psi in the suits, we wouldn't get the bends. The third was preparing the suits for the EVA, and Jerry's starting that here. We checked out all of the suits in case there was a contingency EVA. On the third flight day here, Linda had grappled the GROW with the arm, and here we are preparing to release the latches which hold the Gamma Ray Observatory into the cargo bay. And we are releasing the 4th and 5th of those latches.
After we checked out the pocket, checked out the systems as much as possible, and Jade released those latches, I used the arm to start lifting GROW out of the bay. Now this is a 35,000 pound payload, the heaviest we've ever moved about on orbit with the arm, and while it doesn't weigh anything, it has all those properties of mass, so you have to move it very, very slowly. Except time seems speeded up a bit when you're actually doing this in the aft flight deck of the orbiter. So you can see there all the appendages are still stowed. The arrays are folded up like accordions on the left and right side, and you can see the end of the high gain antenna dish underneath there still folded up. We moved it straight up out of the bay to what we called a low hover position, and then put the arm into an automatic mode that basically just moved it a bit in translation, but mostly pitched it over about 110 degrees. And once we got the arm up to that position, that was where it was to have stayed until a release. Here you see it after the first solar array has been deployed, and that went just like clockwork. Matter of fact, the whole arm ops worked very smooth, and we were on the timeline here. The other solar array you see actually in the process of being deployed. And the next step in the deploy process, after we maneuvered to an attitude Steve did that to start charging these, was to deploy the high gain antenna boom.
Once we realized that the nominal and several other attempts would not release the high gain antenna boom, it was time to begin preparations for the EVA means of unlatching and deploying the boom. Here you can see Steve assisting Jay with his lower torso assembly, while I was in the airlock helping to prepare Jerry, who was already inside of the hard upper torso of the suit. The EVA was one that we had trained for and prepared very thoroughly for. GROW was designed for a lot of EVA work to be done on it, and we performed a unscheduled or quick response EVA to take care of a problem that someone fortunately had foreseen. Here you can see the 2 crew members exiting the airlock to begin their work.
Well, as Ken said, we had thoroughly trained to be prepared to react to spacecraft contingencies such as this, and we were out on the spacecraft very quickly, surveyed the situation, did not see anything that should have been causing the boom to hang up, and with some relatively easy force inputs were able to jostle the boom free. Analysis now says that probably there was just a little bit of thermal cover on the boom that was hanging up on some of the spacecraft structure. I think at this point I yelled gleefully, "It's free, it's free." As far as I was concerned, when that boom came free, that made my flight for me. It was the only reason that we went on this spacewalk, and with the successful freeing of this boom, we then translated over to the other side of the spacecraft, where Jay and I completed the task of putting the boom into its on-orbit position. You can see this other view now. I'm in a foot restraint, and Jay is supporting me and watching my legs to make sure that we don't do any damage to the spacecraft as I very slowly and gingerly raised the boom up to its full deployed position, and then with a wrench was able to drive a mechanical system over center which locked that boom into its on-orbit position. Then Jay and I quickly left the spacecraft so that the POC could turn on the spacecraft's transmitters and receivers and fully check out the spacecraft in preparation for release. And during that time, both Jay, as you see here, and me in the other window had a chance to come up and say hi to the folks inside and see what they were doing. I think they were eating at this time, Jay, if I remember right,
we were
while
busy.
we were outside
very
working.
busy.
We're saying hi through the window to them there.
Well, some point after that, as a matter of fact, it was a good bit of time later, the arrays, we moved it back up to the release position. The arrays were fully charged. The POC finished testing out all the systems. It looked really great. We were ready to release GROW, which we do by opening the snares on the arm and very carefully backing away so as not to provide any rates on it, although a 35,000 payload is pretty stable up there in space. That's what we found out. We waited, and as soon as the arm was clear, Ken called that to Steve.
When the arm was clear, of course, it was called to me. We just reset the digital autopilot and put some pulses in to move slowly away from the GROW. It appeared to be as slow as you see in this film, so slowly that I checked our displays to make sure it was the right rate. But it was about a half a foot a second, which is just a slow drift away. There's a little thing you see fly by in this picture which caught my attention at first too. It was a piece of debris in the lens of the camera itself, which the first time I saw it I thought there was a piece of something coming off the orbiter of the spacecraft, but it wasn't, of course. We slowly drifted away and watched it go away from us, and then set up for 2 more separation burns, the second of which was about 22 or so minutes after this first one, and it was out of plane a couple of feet a second just to get out of the orbital plane of GROW. Here you see it going away. And the third was called a posigrade separation burn, which got us above and behind the orbit of GROW. And then later we came back to within 8 miles of it for a separate test. Here's just a shot around the cabin. You'll see a lot of cameras over there on the left side, and we took a lot of pictures of the ground on this flight with Hasselblad 70 millimeters, and also the big one you see is the Arrow Linhof, which we fly quite a bit. The flight deck was relatively uncluttered. As we pan around to the right-hand side, you'll see our ham shack, and we're all licensed amateur radio operators, although I have to say Ken is hands down the most experienced, so he was the senior ham on the flight, and he did quite a bit of operations with the equipment. You see just a few cables over there on his side, which he kept quite well under control, I might add. And back on the other panel are our recording devices, 2 orbiter VTRs and a separate one that we flew. We had a list of secondary experiments and tasks. It's too long to elaborate on here for you, but this is just an example of one of them, a little air sampler that we would change positions on each day. I chose all the hard experiments to do like this for myself. All I had to do was reset it and log a time that I did it.
Jerry and I worked on another one of the mid-deck experiments that we had. Its acronym was SHARE. It was a very small abbreviated version of a heat pipe that they hope to be able to design someday for large space structures. And the idea is you move fluids around by methods that are supposed to work in zero-G, such as wetting and capillary action. But the problem we keep seeing up there is we get a lot of bubbles in these things, and they don't settle out without gravity to make them rise to the surface. And so we just did some more work on them, on transferring fluids around, and a couple of test articles that we had, and were able to send down some direct camcorder video to the ground to show what we were doing.
At the end of a successful deployment of our primary payload and EVA, as you might imagine, our spirits were very high, so much so that we decided to celebrate that evening by having dinner on the ceiling. And dining in the middeck is quite an experience. We're all in different orientations, and as you can see that we were quite informal, and in fact table manners were somewhat optional. Dinner was very good. Food on board the Space Shuttle is excellent. We had a good galley, and we all sort of pitched in. Whoever was free took over the duties of preparation. When we got to the end of the meal, Jerry provided the dessert, and he dispensed the malted milk balls here very equitably, I thought. However, his aim was sometimes off. Actually, we had very little time on orbit on our timeline, and it turned out that the few moments we did have to relax were very precious.
On the fourth flight day, we performed the planned EVA for this mission, which has as its principal objective to do flight tests on 6 different ways of getting around large space structures. We had the idea that this was going to be 5.5 years before we did this EVA, not about 12 hours since the last one. But it made it just as sweet nonetheless. Here we are doing one of those types of translation methods, and that's where you put your feet in a cart that is able to slide along a rail and propel yourself by hand motion. We were testing whether you needed 1 or 2 handrails to do that. It turns out it's very easy to move along. You can give yourself a couple of pulls and go all the way to the end of the bay. We constructed this rail all the way down towards the flag there at the end of the bay after the Gamma Ray Observatory was deployed. The second method that we tested on orbit was a kind of a railroad handcar that you can see in this view. Of course, one thing most people don't realize right off is half the EVA is going to be at night, and visibility was excellent. We had no difficulty, and some of these tests I don't even remember if it was day or night. That worked well, and we also tested a new type of leg restraint device that the engineering community here at the Johnson Space Center had developed. The third method was a kind of motor generator set in which the operator hand cranked a generator, and the electricity thus produced was transmitted to a motor down by the foot restraint. Again, that worked very well. We found some surprises, all of them good. These work much better in zero-G than they do on the ground, proving again the value of flight test for any of the space station gear. This, for space station or any large space structure, we learned quite a lot, not only here, but of course in the shuttle heat pipe radiator experiment that Linda just described in the middeck. Another method of moving around that we wanted to test was a way of keeping your safety tether along with you and making sure that you didn't have to tether to a point way at the end of the truss on a large space structure. I'm holding here what we call the tether shuttle, which was the transport mechanism for my safety tether in this test. We also used it to move around. Here we are ingressing the foot restraint on the remote manipulator arm. Linda had maneuvered it down to where we could put the foot restraint in there and use it as kind of cherry picker. And one of the objectives of the EVA was to find the most efficient ways to use the remote manipulator arm as a work platform in the construction that we'll be doing from the shuttle in the future. It turns out it's an extremely stable platform. It moves very smoothly. I keep telling before the flight, I told Linda that was operator technique, and we must have buttered her up good because she did great. It was outstanding. It's a great way to move around. It's a great way to do work, and it gives you some spectacular views of the shuttle that I think you'll see in some of the slides. We also, at the same time that we were doing this, we're testing how much force an astronaut can exert to free a bolt, how much loads he then puts into structure so that sophisticated engineering folks can figure out how strong the structures must be. Here, Jerry and I swapping places on the manipulator foot restraint, which we did near the end of the second EVA, and this activity brought to the close what we called the EVA return to flight. And it was the first set of EVAs in 5.5 years, but it sure won't be that long again. We're getting ready to do the next EVA mission in April of next year, and after that HST repair, and then moving on to space station construction.
We were very fortunate during the flight. We had a lot of cloud-free areas that we were interested in observing from space, and we were able to shoot a lot of film and video out the window as well as a lot of still pictures. And this is one of the scenes coming up on the Middle East over the area of Kuwait. And I guess we could very vividly see from the shuttle the unfortunate occurrence of all of the oil fires down there and the smoke plumes and just the big smoke clouds that were being formed.
Here's a pan across Southern California as we flew by. The white you see near the top of the screen is the snow on top of the Sierra Nevadas. I guess they've gotten near 60 to 75% of the average snowfall all came late in the spring. The San Joaquin Valley is to the left of the scene as you come down, coming into the center now. The V-shaped valley is the Antelope Valley or the high desert. In the center of that you can see Edwards Air Force Base, or at least Rogers Dry Lake Bed. It was a panoramic view.
These next two views are sped up to 4 times what we actually saw, and you're going to have to stand or lay on your left side to actually see this one correctly. What you're seeing here is the entire southwest of the United States, all the way from the California, Mexico area, across Arizona and the Grand Canyon area, and in a little while you'll see a white spot about in the middle of the frame coming into the top of the field of view, and that's White Sands, New Mexico. Absolutely beautiful view of all of southwestern United States. There's a White Sands coming into the field of view right now. Second view again sped up at the same rate is as we approach the southwestern coast of South America. The Andes down there are just absolutely beautiful to look at. You can see how rapidly the coastal plain of South America rises into the highlands of the Andes. You can see the large salt pans out there, as well as all types of indications of volcanic activity in the not too distant past.
One of the secondary experiments we carried was an amateur radio station called Shuttle Amateur Radio Experiment. We used this equipment, which was all put together by amateur radio enthusiasts, to contact students across the United States and share our spaceflight experience with them. We also talked to students in Australia and people in South America and Africa. As you could see, we also got some gymnastic exercise. We thought that some of the maneuvers performed on orbit were skillfully executed. We rated Linda 10.0 for enthusiasm on that last rolling maneuver. And we found that in general, the zero gravity experience was one that we all enjoyed. We adjusted to it very well and had quite a good time. We found that we had skills and abilities that far exceeded those we had on Earth. Following the second EVA on flight day 5, we began our flight control system checkout. This is when we begin to prepare for return to Earth, and we exercise all the aerodynamic controls that we will need upon re-entry to the atmosphere to begin our transition from spacecraft to aerodynamic vehicle again. Here you can see the elevons being cycled through their full range of motion. This exercises the hydraulic systems, the actuators, and we perform diagnostic tests on all of the displays and controls that we'll be using in the upcoming re-entry evolution. For re-entry, we get back into the orange launch and entry suits. These suits provide us with protection from reduced atmospheric pressure. They provide our communications and thermal protection. And also something that might not be so apparent is that they provide anti-G protection in the form of a G-suit, which is very similar to what is worn on a high-performance fighter. After a week of 0 G, a single G, or perhaps 1.5 to 2, feels like a tremendous load. And so we, here you can see we take on additional fluid. We actually load our bodies with prescription water and salt indicated or provided by the doctors, so that we can begin to recover some of the blood volume, which is normally reduced during orbit.
The deorbit burn was done, actually we delayed a day as you all know, so we came in on the 7th day. Deorbit burn was done over Africa nearing sunset, and we flipped around and flew the whole entry at night to arrive at a sunrise over California. And that's the view out the forward windows. You see the bright flashes on the back of Ken's helmet, and as you Linda turned the camera and looked out the overhead window back towards the tail, that's actually looking down the wake of the airplane behind as the superheated air is reconverging behind the airplane. It was quite impressive, to say the least. There's the approaching sunrise as we're just coming up on the California coastline. And quite a beautiful sight. The entry was perfectly normal. We had several program test inputs, as they were called, which are automatic inputs to the flight control system to perturb the Atlantis, get additional aerodynamic data so we can fly it further forward centers of gravity. We entered the heading alignment circle and came around to land. The landing was a low energy landing for a couple of reasons. I got a little bit low energy on the heading alignment circle and was slowly making it up. And as well, we had some rather unusual winds that were of high velocity down to lower altitudes, so that the two of those factors translated into a lower energy but safe touchdown. You see one of the advantages of being able to carry a camcorder on a flight. We've got some footage that we were never able to get before out the windows, and Linda was holding that camcorder tethered, and that last scene was looking, and that scene there is looking out one of Ken's middle windows, looking forward into the side as well, so you can get a real feel for how it looks out the window. We pre-flared and lowered the landing gear at 300 feet and then came on down and touched down. It was a real nice day at Edwards. The temperature was around, I think, 37 degrees when we landed, and it felt really nice when we got out. We landed on Lake Bed Runway 33, which is one that has not been landed on before by the shuttle. There was a braking test which we did to apply light braking. This was the first flight of Atlantis with carbon brakes on the wheels as opposed to the beryllium which we'd had before. They worked fine. There was no adverse effect of those brakes at all. They felt real good. So we rolled to a stop, went through the post-landing switch list to power things down and get the Atlantis ready for a handover to the ground crew, and then got out. We did the typical handshake at the bottom of the stairs and then a walk around to look at the Atlantis, and at a glance, and also from reports we've heard after the flight, it was in real good shape. It suffered very little damage to the tile, both from the ascent and also from landing on a lake bed, and that ended the STS-37 flight.